Good morning. We're here with Randy Bartley and Bair as part of the 4C webinar series. Thank you, Randy, for presenting again, and thank you for presenting on the FTIR analysis with ASTM 6348. With that, oh, I forgot one thing. You have to, if you're going to ask a question, there's a little show conversation icon on the upper right-hand side. And if you type that question in, you type the question in on the lower right-hand corner, and I will type question here now. And if a question comes up, just type that question in there, and then at the end of the conclusion of the webinar content, then I will go through those questions with Randy. So without further ado, Randy, take it away.
Thank you, Steve. Appreciate it. We're working on one little technical thing, and we'll be ready to roll in just a second. Steve, can I get a thumbs up if you can hear me?
Thumbs up. I had muted myself. Thumbs up.
Okay, thank you. Well, good morning, everyone. Thank you to Steve Probst and 4C for allowing us the opportunity to bring this presentation to the platform. Very thankful that you've set us up for this, and thankful to all of the participants or attendees. Hoping that, again, this is an informative view of the ASTM method. My name, again, is Randy Bartley. I'm the CEO of Bair. I've been in the industry for 25 years doing air quality consulting and services. I'm a member of the Source Evaluation Society. Our company is an accredited lab within the state of Louisiana's in the LELAP program. 5 years ago, I had the opportunity to do the first emission testing presentation at the Gas Machinery Research Council. We presented on method changes back then, really dealing with single point testing and stratification test on compressor engines. Last year in February, I presented at the 4C conference. I co-presented at the TCEQ conference in March of last year. I think that was probably the last event that was held before things started shutting down and everyone started doing webinars as opposed to live conferences. This platform, the 4C HSE Webinar Series, I actually did the first presentation, as Steve alluded to a few minutes ago, back in November, where we did cover a broad range of methods, method updates that have recently been implemented. And really, we had a good focus on issues that we see commonly at the stack level with port setups, how to tie into stacks the right way, and trying to overcome improperly designed stacks. So if you would like more information about that, please go back, as Steve mentioned, and take a look at that presentation, and hopefully you'll get some good pointers out of there. And then recently I was asked to join the ASTM D6348 rewrite committee, and about 2 or 3 weeks ago attended my first committee meeting, and very thankful to be a part of that committee. Today we're going to blow through some of this very quickly, but again, the presentation is recorded, and if you have any follow-up questions, we will make ourselves available to answer any questions that may go unanswered in this time that we have today. But we'll focus on recipe and method building briefly, on-site field analysis procedures, Post-test data validation, big topic here that we're going to focus in on. These points are follow-ups to about one slide that I showed back in November. So really going to get into the meat of it. And then we'll talk about 4 common issues that we see with the method and test companies having either difficulties in full adherence or full compliance with these points as we go through this. Most of the work that we do, that Bair does, is in the natural gas compression industry. So we're testing on gas compressors, gas turbines, generators. We have done some diesel testing as well. That would be a part of 40 CFR subpart Quad I. But really our focus is Quad J testing, Quad Z testing, turbines under Quad K, and then anything required under NSPS 60.8 as far as initial test for some of these engines and sources, and then other state requirements, for example, in the state of Texas, where you may have 117 non-attainment area requirements or PBR biennials under Chapter 106 in the Texas Administrative Code. But anyhow, getting into the method here, there are 8 annexes that deal with data quality objectives within the ASTM D6348 method. There is an EPA reference method that is very similar to the ASTM method. That would be method 320. We will not touch on method 20. Our focus will simply be the ASTM method today. So we will take a look at all 8 of these annexes. Some of them we will brush over very quickly. Some of them we will spend a good amount of time working through those. So Annex A1 defines your test plan requirements. A2 is how you determine your minimum detectable concentration of your target analytes on the day of testing. A3 is the collection of your reference spectral library. A4 goes through your pre-test procedures and some of the post-test procedures. Annex 5 deals with a spike recovery, analyte spike recovery test. Annex 6 goes through determining your system performance, making sure that everything looks good within your sampling system. Annex 7 is the preparation of the algorithm, the software used to quantify your target compounds. And then Annex 8, we'll spend some time on. This is probably one of the largest areas of contention, or where questions arise in how do you do Annex 8, when is it required, and what does it look like? How do you report it? So before you step out into the field, you're going to have Annex 3 and Annex 7 taken care of. Annex 3 is the collection of your reference spectral library. This is typically commercially available and typically provided by the FTIR instrument provider. So we use MKS instruments or FTIRs currently. So their MG2000 software program has all of this loaded up for us. We can get our recipes for gas sources or diesel sources, modify the recipe or the method within the software program to look at different sources that are burning or running off of different fuel sources. So, and then Annex 7 is the preparation of the algorithm to quantify the data that the analyzer captures on the day of testing or during testing, I should say. So after you've got those typically provided by the manufacturer, you would get into Annex 1, which would be your test plan. And these are simple things like what's the applicability here? Are you testing against a regulation like Quad J? And if so, how many test runs are you going to do? 3 1-hour test runs with your sample being or samples being recorded and every minute over the course of the 1-hour test run. You'd want to identify the source that's being tested. You'd want to have a process description of that source being tested. You'd have a schematic of your sampling system. You'd want to know how high the point of sampling is from grade and access to the stack and test ports. You'd want to have a good analysis of any safety concerns or safety issues before you get into the field. Other things that you kind of want to know is what's the approximate moisture content of the effluent or the stack you're going to be sampling from, possibly want to know what the CO2 content is, and that will deal with some of the ranges in which you're going to look at during sampling. Pre-test preparation that occurs on a daily basis in the field is kind of in a combination of Annexes A4, A5, and A6. And I want to stop right there. Again, I mentioned these annexes don't flow linearly or in a process. When you look at Annex 1, that defines your pretest. But these annexes kind of skip around. So if you're reading the method and trying to say, okay, I'm reading the data quality objectives in the annexes, it doesn't really go in order of how you actually conduct a test. So want to make that clear. The way that we're going to present is actually in that process flow as to how you would want to prepare for and conduct a test. So annexes A4, A5, and A6 have your pre-test requirements, starting with getting a background of your instrument in the field. So you flow nitrogen, you want to have a baseline level for all of your target analytes, for your moisture, for any tracer compounds that you're going to possibly use for your spike recovery. And as a general practice or best practice, we like to take screen captures during these daily checks and dump them into our test report. This was something that MKS trained us to do when we started using FTIR analysis. This was also something we used Prism Analytical, which is now part of Montrose Environmental Group. We used them to do all of our Annex 8 data validations when we first started doing our FTIR analysis. And I know some of those folks are on the webinar or attending today. So a lot of our best practices came from going through training with them, and we still stick by these practices. So you'll find these screen captures in our reports looking at single beam linearity. And what we're looking at in this top left portion here with the red circle and the blue arrow, we're looking at the voltage of the FTIR at 250 inverted centimeters, and we're trying to make sure that we're within plus or minus 0.005 volts. If we're not within that range, it means the analyzer is not linear. And I want to put this in the simplest terms as possible. With your reference methods, your traditional EPA reference methods, you would typically do a 3-point calibration for any compound of interest to prove that the instrument has linearity. Well, with the algorithm and the software here, if you're calibrating carbon monoxide at 50 ppm, you can stand by that calibration, and because of linearity within the software here, you can the assumption is that if you were reading or seeing 500 ppm of CO, that the instrument is calibrated to that level as well. Some other checks and screen captures that we put in. We want to see what the single beam max intensity is. So again, looking at the upper left-hand portion of the screen here, circle in red shows that we are at about 1.6 volts of single beam strength. And when we drop below about 1 volt, we know that our instrument needs to have some maintenance done. We could have dirt or dust or some type of particulate within the gas cell, or maybe we took a slug of moisture within the gas cell. It could have fogged the mirrors. You could have moisture contamination on some of the internal windows that are all going to affect the single beam strength. And so as that intensity degrades, it just tells you, it's an indicator that you've got maintenance to do on the instrument. And then one of the last checks that we take a look at is the water peak analysis. And this shows us how good the resolution of the analyzer is, how good our pictures of the spectral analysis is going to be once we take a look at this. So things that we're paying attention to on this screen is what's called the full width half height. And you see the two circles down in the bottom right-hand side of the screen. You've got sample peak. And sorry, this is cool technology, but I can get out of the screen and I don't quite get to point all the way over there. But the middle is the sample peak analysis, and then the far right circle is the reference peak analysis. We also look at the original laser frequency versus the calculated laser frequency. and the waterline frequency and compare those. Again, these are very quick checks. Takes about less than 5 minutes to really take a look at these things, but they are indicators of if things aren't looking right, we may need to do some maintenance on the instrument before we can continue with our testing. So continuing on with Annex 4, this is where we get into using a calibration transfer standard, which is typically ethylene as a calibration gas. And this is a great direct in-system check on the analyzer. And the method says we would run some ethylene or CTS directly to the analyzer, to the gas cell, and through the system. We're checking for leaks here, looking at system performance. We are also getting the mechanical response time of the sampling system. So you can see on this screen, the top box, we're showing ethylene, showing the cylinder value. The box below that, the direct measurements. The pre-test CTS reading was 99, almost 100, and our bottle value was 96.3. We want to be within 5% of the bottle value there. So we do that on a pre-test capacity and a post-test capacity. And then we also do a pre-system test. Again, run in the CTS, the calibration transfer standard, through the entire sampling system, getting our mechanical response time. So we see here that we had a 15-second rise of the CTS through the system, 15 seconds for us to achieve 95% of the bottle value. And then we run a zero gas or nitrogen through the system to, again, see how long it takes us to drop below 5% of the CTS reading. So we do these checks again on a daily basis, and not only do we do them with ethylene as a calibration transfer standard, but we also take a look at all of our target analytes. So for a quad J test, you're looking at CO, NOx. You'll use NO as a calibration gas. You'll look at propane for your VOCs, and then with quad Z applicability, you'll look at formaldehyde. And currently, you're allowed to use surrogates. So for formaldehyde, you'll get a calibration gas. Typically, acetaldehyde is used as a surrogate. The reason being, acetaldehyde is a little more stable within a bottle, and you have a longer certification as far as that bottle expiring and not being able to be used. So this is one of the elements that has been discussed in the rewrite committee as to are surrogates going to continue to be allowed when there are commercially available, readily available compounds that are exactly what we're looking for. So again, same procedure as the CTS. You do a pre-direct calibration, a pre-system check, get your system response times, and do a post-direct calibration. The post-direct calibration and pre-direct on your target analytes is not a requirement. This is something that we do as a best practice to ensure that we are seeing everything that we want to see within the test program. So this slide again just shows from one of our tests that was conducted recently that we hit all of the requirements of the method. Feel free to review this at a later time. We really want to get into more of the meat of what we're looking at. And this screen here, Annex 2, this is one of the this is something that gets missed sometimes, I think, from service companies, and how to appropriately conduct your minimum detectable concentration for your target analytes per your test program. There's 3 different ways currently within the method to determine your minimum detectable concentration. We're going to walk through an example of MDC number 2. This is a very commonly used calculation of your minimum detectable concentration. And so essentially what you're doing is taking 8 samples through the system by running nitrogen through the entire system. You wait for all of your target compounds, your moisture to equilibrate. You really want everything at 0 or as close to 0 as possible. And you set your scan time to an equivalent time that at which you're going to be sampling for your test. So again, for a quad J test, if you're doing a 1-hour test with recordings captured at every or 1-minute intervals, you'd like to do this MDC at that same 1-minute interval. So this part of the pre-test calibration requirement takes about 10 minutes or so, 12 minutes once you get to having everything equilibrate. And then essentially what you're doing over those 8 lab samples that you're taking, you take the average and the standard deviation, which becomes your standard deviation is your NEA, your noise equivalent absorbance, and then 3 times that standard deviation becomes your minimum detectable concentration for your analytes. So what we've done here in this run screen is we collected data from over 4 days of testing to illustrate to the group here that when you're doing your MDC analysis, these values are going to be different from one day to the next on the same instrument. So this is same instrument 4 days in a row, and we'll show this in a few different formats, but top of the screen, top left is looking at our NO, right here in this box, CO, down here at the bottom, we've got butane, and then right top would be NO2, propane, and formaldehyde. So again, you can see in a run screen capacity, we can also take a look at this from a PRN. Oh, excuse me, it got hung up there. Let's see if this will run. Okay, so you can see here, if you look at the date column, I think we only captured 3 days here, January 11th, 12th, and 13th, but you can see that we're getting the MDC each day, and we look at all of our target analytes. The PRN file is way too large to be shown all in this one screen, but you can see here you've got a good raw data log. It shows you your date and the time of sampling. Data logs, as you may or may not know, are required to be put into your test report. And this is a great way for auditors to go and look at, hey, does the data from the raw data logs line up with any of the information entered into your summary tables or calibration tables? So very good information to have there. Again, this is just one more way to look at this, the NEA and MDC tables over the course of the 4 days, January 11th at the top left to the 12th, to the 13th here, and to the 14th here. And you can see on a day-to-day basis, if you just focus on CO column for these 4 tables here, you can see that on the 11th, our minimum detectable concentration for CO was 0.32. If you go over to the 12th, you can see that it was 0.1. On the 13th, 0.27, and on the 14th, 0.19. Not great, not a whole lot of variance here, but it does matter because unlike your traditional EPA reference methods, your MDC is what calculates your system bias. And so if you are not doing this on a daily basis, then you are not able to report an accurate system bias on of testing. And so when you're reviewing a report, if you see the same numbers reported day after day for and it could be an entire fleet of instruments, you would want to ask your service provider, hey, how are you getting these numbers? Are these simply manufacturers numbers that have been provided for minimum detectable concentrations, or did you go through this process one time? This should be a flag to you if you are not seeing this process done on a daily basis. For those that like graphs, same data reported here, and you can see for the different analytes the daily change, again, from the same instrument that we used out in the field. Moving on to Annex 5, doing a spike recovery. This is done to test the transport system. We're looking for leaks here. We're looking to see if we have an equipment malfunction. There are 2 primary ways that you can do this. You can either use a tracer compound, such as sulfur hexafluoride. SF6 is commonly used as a tracer compound to do this check. If you don't have a tracer compound blended into a calibration gas cylinder with your target analytes, you can use mass flow controllers that are calibrated to NIST standards. There is a way to do it without a tracer compound. It's pretty easy to get this done with the tracer compound, and I'll explain this a little bit more as we go through this. The tracer compound also helps to calculate a specific dilution factor. So when you do this process, essentially, I'll try to put this in the simplest terms. The first part of this check is you position your probe within the stack, and you get a native concentration of what the stack is saying for the target analytes that you're looking at. So you record some data looking at your CO, your NO, NO2, propane, formaldehyde, whatever your target compounds are that you're looking for. You want to find out what's in the stack. And then what you do is you come back with a calibration gas bottle that has very high levels of those target compounds blended with a tracer compound like SF6. You go ahead and spike that cal gas through the entire system, overflow the probe, and then you're looking for a certain value to come back for a specific target. And you need to be within plus or minus 30% of an expected concentration. So this is a run screen of a spike recovery. So if you're looking right here in the bottom left, this is the SF6 portion, the tracer compound. So you can see this little rise right here. That's when the tracer gas and the calibration gases were entered into the system. Prior to that, so we're not seeing SF6, or seeing it pretty low here at a 0 number. So SF6 is typically not found in a natural gas combustion stream. That's why it's a great tracer for natural gas sources. So again, you can see this number rise again, and you see all the other target compounds rise once you introduce that high level gas into the system. So feel free to watch this screen over and over again to get a better sense of what's going on here and seeing those analytes rise. And then the method has the calculation that is run for this. And so in the top part of the screen here, you can see that we have a cylinder that has CO, NO, propane, and the tracer compound in it. And that's important again regarding mass flow controllers if you don't have that tracer compound. So with the spike recovery, so looking at the CO box, kind of top middle of the page here, CO box, the engine output was roughly 23 ppm. And so we put in a high range CO level, 3,000 plus ppm, and we got a dilution factor of 7%. You want to remain below 10% according to the method. So you're getting 90% of your stack concentration and 10% of this spiked in cal gas. And so we predicted that we would see roughly 236 ppm for full 100% recovery of the system. On CO, for this spike recovery, we saw a 95% recovery. Again, you need to be within 70 to 130% recovery, or plus or minus 30%. So great recovery on CO, very, very well within the acceptable limits. Our NO spike, you can see it was a little bit lower. Engine output was 50 ppm. We spiked in, or excuse me, the spike average was 213. The predicted value was 261, 262. We recovered about 77% here. And again, the dilution factor is going to be the same for all your target analytes when you have that tracer compound blended in with your SF6. A little bit of a, maybe a complicated process. If we need to do some follow-up on this, or you have some questions as to how this procedure is done, happy to come back and revisit this as needed. What you should see in your stack test report is cal gas certificates for all of your calibration gases, including the one that would have the tracer compound in it. And I've got a couple of notes here. You can see that the circle in red shows that we have the tracer compound blended in with the same in the same bottle as our target analytes, our propane, our CO, our nitric oxide here. And then from the on the right side of the screen, a note directly from the method. Use of a tracer gas compound such as sulfur hexafluoride, SF6 blended with calibration standards at a known concentration allows for accurate quantification of the exact dilution factor, which negates the need to calibrate accurately mass flow controllers and rotometers. It's important to use and to calibrate accurately mass flow meters, mass flow controllers, and rotometers used during the procedure if a tracer compound is not present in the spike gas. So one of the things that came up, a question that came up during a recent SES Source Evaluation Society webinar was, what happens if you have, let's say you're trying to do a spike recovery on propane, but your SF6 is in a separate bottle with a different target compound, but you're trying to do a spike on propane. Well, it comes back to this point. Without that SF6 being in the same bottle or gas cylinder, calibration gas cylinder, you'd want to talk to your service provider, the testing company, and say, hey, how did you do this? Do you have accurately calibrated flow meters in order to run 2 bottles and have an appropriate mix in order to calculate your dilution factor correctly? And then the state agencies or the EPA have the opportunity to come back and say, we would like to see your NIST certifications or calibrations on those flow controllers and rotometers to make sure that you are within or that you are able to do this accurately and that your flow controllers are up to spec. So moving on and getting to the big booger of this whole presentation, manual validation under Annex A. So back in November, I tried to bring to the platform that Quad J regulations state that if you're going to use ASTM D6348 as your method of analysis, that you need to report the data from Annexes 1 through 7. And for some reason, Annex 8 is not written in Quad J tables or regulations. So scratched my head a little bit, talked to the EPA about it and said, was this a typo? Was this missed? And the correspondence that got back was no, it's absolutely supposed to be a part of the comprehensive analysis if you're using this method, and without going through Annex 8, you are not able to quantify the data accordingly that you're presenting from the previous 7 annexes. So what this method or part of the method does, what this annex does, is it verifies that the FTIR software that was capturing the data in the field, that it was capturing it accurately. And the method says you need to validate 2 spectrum per test run. So Quad J test is 3 1-hour test runs. You have to validate 6 spectrum files for your target analytes. The method says you'll take 1 outlier spectrum. So if you're looking at CO, if your average was 25 ppm during the test, go ahead and get 1 outlier where you may have had a reading of 100 ppm or maybe single digit 3 ppm. Pick that outlier spectrum file, and then also pick a spectrum file that's close to the actual average of the test run. And so you go through this process, you view all of your target analytes, and after the manual analysis, which we're going to show in just a minute, you want to compare those values in the manual analysis to what the FTIR software saw on the day of testing. And those values need to agree with plus or minus 20% of one another. So again, we use MKS instruments. I'm pretty sure that FTIR manufacturer has some form of software packaging that allows you to go in and do this manual quantification. So what we're looking at here, hey, Robert, by the way, this camera has stopped recording, just letting you know. Okay, sorry guys. So your manufacturer should have, no, just keep going. Your manufacturer should have this as part of their software program, your FTIR manufacturer. And so here we go. With MKS, you go to the method analyzer, you select a spectrum file and load it into the software, and then you go and select select your target compound. This, I believe, was NO. And then on the right side of the screen here, you're going to see you manually move this bar up and down to quantify the target analyte. You're mitigating all potential interferences. You are trying to get that quant band to remove all the peaks for that target compound or target analyte. And you do this again for every target compound of interest or potentially interfering compound. And you would take 2 spectral files per test run. So this is a little bit of a complicated process to learn. Again, when we started doing FTIR analysis, we sent this out third party to Prism Analytical. We've taken it in-house as of 3 or 4 years ago. Do this our own. It is something, as you can imagine, if you are going to go third party with it, it's expensive, per data set that you've got to take a look at. And again, if you bring it in-house, you still have those expenses, but hopefully, find a little bit better of a return. But the point is, this has to be done. And a best practice in reporting this is, again, to go to a screen capture. Take a screen capture of your final values that you're looking at for a target compound and dump that into your report so that you can show, hey, this process was actually done. And it may be hard to see on some, but there's actual time and date stamps that are up at the top of this, so you can see that, hey, this was from that date of testing. You can identify within your report which spectrum files you took a look at for manual analysis, and auditors can compare, okay, it was lab number 400 or whatever the lab number is, and can compare that. So again, it's just proof, evidence that you've gone through this process. Some 2 software utilities that have been created that have offered a little bit of confusion. One is an automated validation utility that can run concurrently while you're doing your FTIR analysis in the field. This will do things like checking it'll check your pressures on your gas cell, your operating temperature on your gas cell. It'll check your single beam intensity, all of those screen captures that we showed earlier in the presentation. It will run concurrent and make sure that you know that you're good throughout the entirety of your test. But this is not to be confused. This AVU, this software utility, does not take the place of the manual validation that needs to be done in Annex A. And then recently, there's been a development of new software that is being provided to some of the state agencies. And I don't know that all FTIR manufacturers have done this yet, but essentially, in some of the states that are a little pickier about reviewing their reports and want to have a full understanding, they wanted to have a utility that would say, that would allow them to request the spectrum files that were validated in that test report and do their own manual analysis to ensure that they can come close to reproducing the numbers that are reflected in the report, that they can go in, do that manual scaling, mitigating the interferences, and again, find values that are within 20% of what the FTIR showed on the day of analysis. One of the contentious parts of that is, okay, the PRN file and the spectral files will show several different analytes that may not be a part of that test program. And so again, using the example of a quad J test, if you're looking at NOx, TO, VOCs, and if an auditor has the ability to go in and do their own analysis here, they can start taking a look at things like methane or ethane or other pollutants or compounds that are not a part of that test program, or even a formaldehyde number, which would not be part of a quad J test. And so a little bit sticky there as far as who owns that data at the end of the day, and should the agencies be allowed to take a look at that. And for more on that, I believe Phil Copy with Prism, or now Montrose, did a presentation on this in the recent SES webinar. So I think there's if you're an SES member, you should be able to go back and find that webinar presentation where this was discussed in more detail. So, couple of last points here. Again, 4 most common issues that we see. So, if you've fallen asleep, if you've drifted off, if you're looking at an email right now, come back to me right here. These are 4 very important parts that we're trying to bring to the industry's attention when you are reviewing your own test reports before you submit to the agencies. These are the things that you want to look for, because these are the conversations that are actively happening with different state agencies, the EPA. It's part of some of the conversations that are taking place within the rewrite committee. The SES webinar touched on a few of these. And so really what we want to look at here, the 4 things, going back to that noise equivalent absorbance and your minimum detectable concentration. If you have a sense of deja vu, if you're seeing the same values in your reports over a series of days, and these values, this NEA number or the MDC number, does not change, talk to your service provider, ask them what they're doing, talk to one of the industry experts, talk to, go to the SES, go to Dr. Laura Kenner, one of the authors of the method, go to Marty Sparks, go to Phil Copy. These folks are out there. They're going to be willing to walk you through this, help you look at these issues. Again, with the spike recovery for your target compounds, again, you really want to make sure if you're using a tracer compound. If not, let's take a look at the flow control system and the calibration of the flow control system to ensure that it meets all the integrity requirements that you would see. And then Annex 8, the manual data validation, it's either not being done by, you don't see any evidence of this in test reports. You'll want to follow up, investigate that, find out if it's being done, or sometimes it's misrepresented, whether intentionally or unintentionally. I think there are some firms out there that may not understand the full, the requirements to fully meet the data quality objectives of Annex 8. And for example, there's been discussions of test reports that show your post-test system calibration on your CTS as satisfying the requirements of Annex 8. That does not do it, guys. You want to be very aware of this. So that's essentially our presentation here. I hope we've provided some clarity, some guidance here, and happy to try to continue with that and answering any questions that you might have. So I am, let's see here, going to have to get in a position to where I can read any questions that come through.
I can read them too.
Okay.
Would you mind restating?
And by the way,
yeah,
and I've got a couple of my team members on as well, so I may kick some of these questions over to them as these questions are asked.
Who presented on the, and I'm using a term that you didn't use, but the credible evidence aspect of the test data? So that if they're looking at methane versus NOx, and the test method was NOx, but they're looking at methane.
That was, if I'm not mistaken, that was Phil Copy. And Phil, I think you're on this presentation, if I'm not mistaken. You did that portion of the presentation with the during the SES webinar recently, correct?
Yeah, I discussed manual validation and really what to do with the data and how to interpret data and really what to do with some of our findings.
Yeah, thank you. And I think from MKS Instruments regarding the software utility that's been created, Sylvie Charbonnet was the presenter on that, and maybe answered some of the questions as far as who owns that data, and what authority do the state agencies have to request.
And I am super sorry. I'm looking for Sylvie's spelling of her name. just so that it's a part of the webinar record. So if someone is listening to the webinar, they can look at the chat line. So I typed in Phil Copy's name, but I do not see Sylvie. Sylvie, do you mind giving me your best spelling, or someone giving me the best spelling of Sylvie? And Sylvie's with MKS?
Yeah. It should be Sylvie Bosch, Bosch, if I'm not mistaken, and then Sharpeney, Charpeney. I hope I didn't. I'm sure I botched that, but I hope I didn't do it too terribly.
Sylvie, S-I-L. Oh, there it is.
There.
Sylvie,
Thank you, Phil.
Sharpening. Thank you all. Thank you very much. So those are two more resources for questions regarding this test method. They can contact you. They can also contact Phil Copy and also contact Sylvie Bosch Charpenay of MKS. So yeah, all of those, if you use LinkedIn, those are all great connections to go make on LinkedIn now, so that you have a reminder of who to ask for those questions. And Randy, I want to support what you're saying about FTIR and minimum detection limits. The webinar on Tuesday of this week focused on minimum detection limits around FTIR and the California rule, which requires FTIR fence line monitoring. And all of that data is available to the public. So someone went through and evaluated that data and saw that the minimum detection limits basically weren't in alignment with what all of the stuff you're talking about today. And in some cases, the minimum detection limits had drifted above the concentrations that they were looking for. So this concept of minimum detection limits around FTIR, you are right on the money. For FTIR, to use FTIR and properly use FTIR, you have to be focused on those minimum detection limits and really documenting with the test. And for this, that means Annex 8 is part of that documentation it's not inclusive, it's not all inclusive, but it's a part of that documentation around the minimum detection limits. And if you look at a stack test for FTIR and the minimum detection limit is the same number across the entire 3-hour period, you immediately know that these minimum detection limits were not reevaluated properly as part of the validation. Is that a correct summary?
Say that last part again there.
If there's 3 1-hour tests using FTIR and the minimum detection limits are exactly the same for all 3 hours, and they're the same for the test from the day before and the day after, you know that minimum detection limit evaluation is not being conducted properly?
I would I would say it'd be pretty difficult to statistically to get the exact same limits from one day to the next. Yes.
Yeah. And that's one of those things that, industry really doesn't want that to persist, because that's the kind of thing that, EPA and LDQ and TCEQ and other regulators, once they get onto that, it'd be pretty easy just to go back and pull a whole bunch of stack tests that were done sequentially in days by a stack test provider. And if the MDL is the same day after day, week after week, then there's a potential that all of those stack tests could be invalidated, and then subsequently that could be a violation for the underlying company. And that's just probably not a risk that I'm sure every single company that I worked with, they strove to have valid stack tests, and they would not want to pay for a stack test that would not be valid and later turn out to be a violation for them. So yeah, this is an issue. It sounds like it's not terribly difficult. So if you got a stack test that was FTIR and that same contractor provided stack test multiple days in a row, which I think is not uncommon because they usually go from one site to the next. You could just check to see if those MDLs are changing, and if the MDLs aren't changing, red flag.
Yeah, and no, Steve, you're right. It really isn't terribly difficult to do this. Simply running nitrogen through your system to get these numbers. And in a conversation that I had with Dr. Laura Kenner here recently, that was her point. You know, this isn't a terribly difficult part of the method. Why overlook it or not perform it? It's either to gain maybe a little bit of time in the field. We don't really know. But no, you're right. It's not a difficult part of it, but it is something to be aware of.
Yeah. Oh, and I'm sorry, I meant difficult in terms of it's not difficult for the agency to determine that the stack tester is not properly conducting Annex 8 and the other annexes. If the agency got a hold of those stack tests from a particular stack testing company for multiple days, they could just go in and look at those and see that this MDL isn't changing. And I know, as you said, there's some remote statistical probability that you could have the exact same MDL 3 days in a row, but it seems pretty rare given that you're putting those numbers out there to 3 significant digits, and to have 3 significant digits recovery across the same system 2 days in a row would seem to be beyond a remote statistical probability.
Yeah. Yeah. And yeah. So Steve, just to try to, I think we've covered that pretty well. I'm going to try to answer a couple more questions before we run out of time here. Andrew S. says, your note on Annex 5, A4 or A54 is the blending of SF6 or SF6 blending with the analyte required or preferred as it's how do I state this? If you don't use a blended cal gas, then it kicks back to you have to calibrate your mass flow controllers and rotometers to NIST standards. So another way of stating that is if we're using a gas diluter in our lab, those mass flow controllers that are used for that gas dilution process, we have to send that diluter in once a year to the manufacturer to get it calibrated to NIST standards. And so if you don't have the SF6, in my opinion, and maybe someone else can provide a different answer here, if you don't have the SF6 blended within the cal gas cylinder for the target compound that you're looking at, then you might ask, okay, I'd like to see evidence of your flow controllers being calibrated accordingly. And if I'm not mistaken, there is incorporation to those procedures within the method for flow controller calibrations.
Someone asked a question, do you believe propane spiking is a surrogate for all of the compounds encompassed by THC for JJJ as a satisfactory surrogate? Does ASTM 6348 list an allowance of using a surrogate?
We do believe that propane is a large enough contributor to your total VOC concentration for it to be used in this capacity. The main issue is that EPA hasn't defined every VOC compound that they would like to see within, comparing it to total hydrocarbons, where you would sample with method or under method 25A. Using a flame ionization detector. That's one of the other points of contention where states like New Mexico, states like Arkansas say, hey, we don't like the analysis of VOCs for the purpose of reporting them for Quad J requirements. So, certain states have come back and said, we want you to use method 25A, and there are a lot of issues. We do method 25A analysis, and you actually deal with much larger numbers there when you're looking at subtracting out your methane and your ethane to go ahead and report your residual value. And within the calibration parameters, you can almost subtract out your entire VOC concentration just through calibration error when you're using that method. So we believe, and there are other industry experts that can speak to this with much greater authority, that what the FTIR is seeing regarding the VOC concentration and using propane as the compound to calibrate, we believe it to be very accurate and very representative of essentially total hydrocarbons presented, where you're within or upwards of 95% plus of VOCs that would be attributed to that final number.
That's fantastic. Regarding the blending, the K factor impact of FS6 is less than negligible. I have to admit, I have no idea what that means.
Yeah, I guess I'd like to have.
And we can move that one to offline because I may not be asking the question correctly. So.
And then regarding the MDC number 2, number 3 versus number 1. Hey, Andrew McGregor from my team, would you be able to provide a simple answer on this? I mean, technically, no matter which MDL you're using on a daily basis, it's going to be different if the method is followed. I don't know if Andrew's on or if he's muted or if he can.
Let me check.
Yeah. As we understand it, you'll be collecting data for each of the MDCs each day. So you're going to get different numbers no matter which one you're using.
Yeah.
Excellent. Okay. I absolutely loved it, Randy. I loved it. That was a fantastic presentation. Thank you very, very much. And we look forward to a presentation on the similar topic during the 4C conferences. This is obviously something that's in a sort of a transitionary state. So every 6 months or so, we would love an update on the status of this, and you're obviously on that committee. So as that committee makes changes to the ASTM method, we'd love to hear about those and look forward to hearing from you again at the 4C conference, August 18th to the 20th in Austin, Texas. And we so really appreciate the time that you've taken and given to provide clarity on this subject and to provide guidance to not only the regulated community, but the regulators, and also to improve the quality of stack testing that's out there. We all share the same goals, to reduce emissions and to provide better data today than we had yesterday, and to lay the pathway to have even better data tomorrow. And you're certainly meeting that goal, and I really appreciate you taking the time.
Yeah, thank you, Steve. Again, thanks for having us and giving us a platform to try to bring more awareness to this, and again, just trying to make sure that that the operators and the clientele understand what to expect, and yeah, just thankful to have the dialogue or the opportunity to dialogue. So very much appreciated.
4C is all about connecting and collaborating, and you threw a bullseye today. And Phil Coffey, thank you very much for participating today, and thank you for your involvement on the subject. And Andrew McGregor, thank you for providing the answer today. And of course, it's always great to hear your voice. With that, we'll conclude today's webinar. Should not forget to thank all of the attendees. Thank you for taking your time today to better understand this issue. And if there's someone from your organization that you believe would benefit from this webinar, it was recorded. It will be posted on 4C's YouTube channel and on our website. I will also do a social media post with a link to the YouTube channel and the website, and Randy will also do a post on LinkedIn promoting the webinar. But feel free to share, to go onto that website, copy that link, and share that with anyone from your organization. And if your organization would like a webinar to, just for your organization, Randy has offered to do that for several of the attendees from the prior webinar. So that's always something that is out there as an option too. Is that correct, Randy?
Yes. And again, if we need to co-present or do it in a capacity where we don't want to have a company bias. Just from our perspective, we'd be happy to bring in an associate firm that we've worked with or referred work to. Just happy to do that. Really want to bring just industry partners to this and give people the best opportunity to increase their understanding of the methods.
Excellent. All right. Thank you all very much. Thank you, presenters. Thank you, attendees. And look forward to seeing you all August 18th to the 20th in Austin, Texas at the 4C conference. Take care.
Thank you.